Hey guys, welcome to lesson 6.4. 6.4 is transformations of exponential and logarithmic functions. So if you've been doing well with the transformations of functions, then this lesson should come easy to you. Just a little slightly different because of there being exponents and logarithms, but we'll talk about what that difference is. Okay, so not sure why I decided to make these graphs blank, but we do need to draw in. I'm going to give you an example of exponential. So this is for exponential functions. Okay, and how do we know it's an exponential function? We know based on the previous lessons there's either a growth or a decay. So I'm going to give you an example of a growth. All right, so I'm going to have a point here, one here, and then we'll put one here. So remember, the thing with these is you have an asymptote. So my asymptote is going to approach 0 or approach the x-axis. So this is actually the function y equals 2 to the x power. Remember, that is how you know it's exponential if it has an exponent that is a variable. Okay, a couple of things I want to point out over here is when we're talking about translation, remember your horizontal translation was inside parentheses. In this case, if you have an exponent and something is being added or subtracted to that variable, that is going to be your right and left. So you may need to look at this as you go through this lesson practice. All right, how do you know it's a vertical translation? It's being added to the function, not to the variable. So if you want to make a note that this one goes to the variable, this one goes to the function, you can. Now this one though, I do want to make a note that this one affects your asymptote. So if you are shifting your graph up or down, that is going to change what your asymptote is approaching. So see how there's nothing being added to this function? My asymptote is approaching 0. Well, what happens if I shifted or translated my graph up 5 units? Then that my asymptote would be 5 instead of 0. So just something to keep in mind as you go through this lesson. All right. Also notice the difference between the horizontal stretch and shrinks. Horizontal stretch and shrinks are when they're attached to the exponent. Vertical stretch and shrinks is when they're attached to your base. All right, so you may want to make a note of that this is when they're attached to the exponent and this is to the base. That's how you know the difference with the vertical and the horizontal shrink and stretch. And they would look the same. They get, instead of it getting skinnier, it would get like closer to the y-axis if it was stretching. If it was shrinking, it would get a little wider. All right, so here is an example of an exponential function. So let's look at an example of a logarithmic function. So on this one, you can see that this is for logarithms. All right, so notice if it's inside, like we're used to, inside parentheses, you're going left or right. If it's on the outside, we're going up or down. Your reflections, if it's inside or, you know, like this after the word log, then it's going to be a reflection over the y. If it's before the word log, it's going to be over the x. And then your horizontal stretches or shrinks will be after the word log. Your vertical stretches or shrinks will be before it. Now, just like before, we talked about how in this one your asymptote was affected here. We're going to see that with logarithmic functions, this affects your asymptote. All right, so if you're shifting or translating your graph left or right, that changes your asymptote. The reason is because in this case our asymptote is more horizontal. In this one, your graph looks slightly different. So your graph looks similar, but a little different. And here's what I mean. It's kind of like your graph laying over, like laying on its side. So should have used the color. So this way, this is your asymptote. So before your asymptote was horizontal, now it's more vertical. And then it's going that way. So if you need to make a note, this is your asymptote right here, because it looks a little different. And if you want to make a note up here on this one, you can, asymptote. All right, so like I said, if you go back to these as you're going through the practice, it should be no big deal. You should be getting familiar with these, and the transformation should be coming a little easier. All right, so looking at this one, it says describe the transformation of f of x equals 1/2 raised to the x power, represented by g of x equals 1/2 raised to the x power minus 4. So what was added to our original function? Just this minus 4. Sorry, my paper keeps hanging up on something. So just this minus 4 is the only thing that was added to it. So if you notice that this is your asymptote right here, and this is on where y is equal to -4. All right, so in this case, remember I told you if it's translated up or down, that changes your asymptote. It originally was 0, now it's -4. So how would we write this? So we would simply say, just like we have in all the previous chapters, this g of x is a translation 4 units down of the graph of f. Okay, something that you guys, I don't know why domain and range scare you so much. I try to make it simpler for you. I try to give you clues as much to help you as possible. So if you ever struggle with domain and range, I'd love to work with you on it because it's not as difficult. It's just for some reason you guys hear that and you freak out. I don't know. So if we're looking at our end behavior, so this graph is going to -infinity on the x, positive infinity on the y. This one's going to positive infinity on the x, and to y it's going to -4. So it's going in both directions of the x-axis. So that means in this case that your domain is all real numbers. Now, your range is not all real numbers because it is limited by the asymptote. Now, it never touches the asymptote, so it is not actually 4. So the way you would say that is y is greater than -4. So it's basically any values greater than -4 and above. Another way you could write it that you have learned is an interval notation. You could say from -4 to infinity. So this is a parentheses because it is not included, so it's not a bracket. My left parentheses just are uglier than my right one. Okay? So I have a few examples here. I want you to try and see if you could describe the transformation. So write them in your journal. At the very least, if you don't want to write the whole sentence, at least tell yourself if it's a translation, a reflection, a stretch, or a shrink. But remember, if you do stretch or shrink, you need to know if it's horizontal or vertical. And I'm going to do the same just because of the limited space that I have here. So if you will, please pause the video and give these a try. Okay, so here is hopefully what you got for your answer. Now, something I want to point out is this is not a stretch because the original function had that in it. So if you notice, I highlighted what the change was. All of these, like this one, already had 0.5. So that is your base. So I just wanted to clarify that this is not a stretch or shrink, that is your base. So your base has nothing to do with your transformation. If you had a number being multiplied to this, like you had this was in parentheses and something, then we would talk about stretches and shrinks. And we will get to some of those, so we'll see what that looks like. Okay, so hopefully you did well on this. We're going to flip over to example number 2. I don't think I numbered these, but that's okay. So the second question. All right, describe the transformation of f of x equals e to the x power represented by e to the x plus 3 plus 2. All right, so what did we change? This is the only part that was added to it. So, and if you look at your first page, if you have a plus 3 in your exponent, that's a left or right translation. So this one's going left, and this is not attached to that exponent, so this is a translation up. And as you can see here, if you pick to a point and we tested it, would we go left 1, 2, 3 and up 1, 2? We sure would. All right, so the graph of G is a translation 3 units left and 2 units up of the graph of F. Okay, so I do want to make sure that we practice domain and range, because domain and range is something that will carry along through Algebra 2, and if you go to college, they'll talk about domain and range. If you take calculus, the same. So I do want to talk about that. So first off, our domain, this is an exponential function. So basically for all exponential functions, your domain is all real numbers. So the only one you have to worry about is your y, and you just have to worry about that asymptote. So in this case, our asymptote is at the 2, which is what you have here. Remember, this affects your asymptote. So it was translated up 2 units, so our range is y is greater than 2. All right, because our range is everything above where y equals 2. All right, moving on. So let's take a look at this next one. It says, describe the transformation of f of x equals -2 to the x power represented by -2 to the 2x plus 4. Determine when g is positive, negative, increasing, or decreasing. Then describe the end behavior. So we got a lot of things we have to do in this part. So I'm going to try and write as small as I possibly can. All right, so first off, what type of transformation is this? So what changed? We had a negative, we had a base of 2, and we had an x. So the only new thing I see is this 4, and there is a 2 right here in front of the x. I know on my paper it's kind of funky, and I hope that didn't show up when it copied. Yours might be a little better, but hopefully it's better. Anyways, if not, there is a 2 here. I'll write it up here just because mine is. So we have 2x and then plus 4. So the 2 is different. So if you look back at your first page, if you have a 2 in front of your exponent, for example, like this is a shrink by a factor of 1/2. So it is a horizontal shrink by a factor of 1/2 because we have a 2. All right, so we know it's a horizontal shrink by a factor of 1/2, and then this 4, you should have this by now, means that it is a translation 4 units up. So go ahead and write that on your paper. Okay, so there's your transformation if you needed it to help you write it down. Okay, so we described the transformation. Now we need to look at when is our graph positive. All right, remember, positive is when your graph is above the x-axis. So we need to see what is that x-intercept. So right here, if I look, I know that this is the point 1, 0. So that is how it's going to affect my positive and negative. I'm using this. So when my graph is above the x-axis here, my values are going to the left. Well, what is to the left? Negative values. You could also say to the left is less than. So if your values are going this way, you're going to use the less than sign. If your values go that way, then you're going to use the greater than sign. All right, so we would say when it is positive when x is less than 1. All right, also, so we got positive, we need to say when is it negative? So remember, negative is just the opposite. When is it below the x-axis? So when is the red part of our graph below? So it starts at 1 and it's going, it's very steep, but it is going towards positive infinity on the x, and it's going that way, so we would use the greater than symbol. So we would say when x is greater than 1. All right, so positive and negative, remember from previous chapters, that's above and below the x-axis. All right, so now we need increasing and decreasing. So, increasing or decreasing. Sorry, I didn't mean to put and. My apologies. All right, so we start at the leftmost point of our graph. Our graph always goes down. So if you are asked to fill in both for increasing, you would say no real numbers because it never increases. All right, and we would say it decreases over the entire domain, which is all real numbers. Oh, not increase, lady, decrease. So decreases over the entire domain. Which is all real numbers. So they may give you that option just to put all real numbers. So increasing would be no real numbers. Decreasing for this one would be all real numbers. Sometimes Big Ideas does it that way. All right, last one, end behavior. Everybody's favorite. Guys, if you do not have end behavior now, please do not put falls left and to the right. That tells me you looked it up. Falls down and to the left. That tells me you looked it up. If you do not understand end behavior by now, please talk to me about it. It's really not a hard concept. All right, so in this situation, where is my graph going? So my graph is going, my x values are negative, my y values are positive, because it's going to keep going that way, right? However, because it was moved up 4, we know our asymptote is 4. So we know we have an asymptote right here. So that is going to go into our end behavior. All right, so we would say as y approaches 4, x is approaching negative infinity. So the asymptote in this situation changes your we don't use the positive infinity, we use the asymptote instead. And then this side is going to positive x, negative y. So we would say as y approaches negative infinity, x approaches positive infinity. So that would be your end behavior. All right, you do have some self-assessment questions I would like for you to try. So please pause the video. Give these a try, and you will get the answers in the next video. So you don't have to pause it. I guess you can just end the video and give these a try.